Morning everybody, welcome to the last maths lesson of this half term. So we'll get started with our Fab 4. I thought we'd have a bit of a recap on our conversions from litres to millilitres. So what I'd like you to do, I'd like you to pause the screen in a minute and I'd like you to convert these litres into millilitres. So let's remember that 1 litre is the same as 1,000 millilitres. So remember, if we're in litres and we're converting to millilitres, we're going to be multiplying by 1,000. So pause your screens, have a go and come back with the answers. All right, so here we are, number 1. 1.4 litres is the same as 1,400 millilitres. Number 2, 0.38 litres is 380 millilitres. 12.7 litres is 12,700 millilitres. And 0.04 litres is 40 millilitres. Now today we've been looking over the last 2 days at area and perimeter of rectangles. Now we're going to be calculating the area of a shape called a parallelogram today. Now in order to do this we need to be able to recognise and describe a parallelogram, and we're going to have a look at 2 ways of calculating the area. First by turning it into a rectangle and then by using a little method where we multiply the base by the height. So first of all then, we need to think about what is a parallelogram. Can you remember? If you've got a piece of paper, can you quickly sketch what one looks like down? If not, here you go. This is a parallelogram. Now, what do we know about a parallelogram? It is a quadrilateral, which basically means it's a shape that has 4 sides. And it has 2 pairs of parallel lines. Now, what that means is, in fact, this should probably be drawn in a slightly different way because I think that these should have 2 arrows on them like that. Now what it means is that the line from A to D is parallel to B and C. So those 2 lines are like this, and if a line is parallel it basically means they will never ever meet. The way I always remember parallel lines is that I think of a train track. Those 2 main parts of the train track, they never ever meet. Because if they were to meet, it would be a nightmare for the train, wouldn't it? So parallel lines are completely straight in line with one another and they will never cross and never meet. Now a parallelogram has got 2 pairs. So you can see A to D, B and C, they're parallel, and A and B and C and D, they're parallel. I often like to think of a parallelogram as a bit of a wonky rectangle because it's like the rectangle's gone, isn't it? And that's a parallelogram, okay? Now you can see here, these are the 3 main measurements that you will always see on a parallelogram. You'll see the length, which is often called the base. Now it's not always at the bottom of the base, it can be in different parts of the parallelogram. This is just an example. So you've got the base, and you've got the width, which is in blue, and that's the length of the width of it. Now actually that's not as important when we're calculating the area. The piece that we need that's the most important here is the height. The height and the base are the 2 measurements that we need. Now to work out the height of the parallelogram, can you see that it meets the baseline at a right angle? So if we had a protractor in front of us and we measured that, that would be 90 degrees, okay? Now that is what we call, when a line meets another line, at a right angle, that's called a perpendicular line, and this is called the perpendicular height. So we need to know the height and the base in order to calculate the area. Okay, so let's have a look at our discover. So we've got 2 children here, Jen and Richard. Now Jen is saying, how can we find the area of 1 tile? Now can you see down here, 1 tile is like, there's a blue one, then a white one and a blue one. And they are all parallelograms, like our wonky rectangles. Now we've got 30 centimetres here, which is our base. We've got 25 centimetres going up here, which is the width. And then we've got our 20 centimetres, which is our height. You can see the little right angle symbol up here. Okay, so then 20 centimetres is the height. Now, there are 2 ways, like I said earlier, that we can calculate the area of a shape like this. Now, Richard has seen if we move the triangle to the other side, so when he's saying triangle, he's sort of meaning this bit, so like the height line, the width line, and then that little bit across there. He's saying if we move it over to the other side, we can then change the parallelogram into a rectangle and then find the area. So it looks like this. So can you see here where we've got the height, and then this little bit of the parallelogram is like a triangle. So look, he's popped that over here. And so what actually results is you end up with a rectangle. And then we know how to work out the area of a rectangle, don't we? Because an area of a rectangle is the length times the width. So here we would do 30 and we would multiply it by 20, which would give us an answer of 600 centimetres squared. So that's one way. Now you're going to be doing a bit of this in your books today, where you're going to be looking at the parallelograms, and it's going to move part of it to change it into a rectangle, and then you calculate the area that way. Now, two other children, Max and Emma, they find the area of one tile by multiplying 23 by 30. So Max has thought, right, well, I'm just going to treat it like a rectangle, and I've taken the 30 centimetres length and I've multiplied it by the 25. And by doing so, he's got an answer of 750 centimetres squared. Now, Emma has taken the base and she's multiplied it by the height, and she's got an answer of 600 centimetres squared. Now, we've got to decide who has got the correct answer. Now, Max's method, where he's done 25 times 30, is that he's treated it like a rectangle and just multiplied the width by the length. Now, because this is wonky, it doesn't work. So in order to find the area of a rectangle, if you're not doing the bit like the previous slide where we were moving part of it to create a rectangle, you can use this, where we think an area of a parallelogram is the base times by the height, and the height is, like I said earlier, the perpendicular height. So this line meets the baseline at a right angle. So actually, when we're working out the area of a parallelogram, this width line of 25 centimetres, we just don't need it at all. It's only the base and the height that we need. So let's have a look. These are the two ways now. So in our think together, first of all, I'm showing you parallelogram A. Now this is using the method where we're going to move past the parallelogram to form and change it into a rectangle. So can you see here that what they're doing, this part they've noticed is the triangle at the end, because you've got here a straight edge which creates the width, and they're popping it over here. So actually now this bit will fill in down here like that. So actually shape A has become a rectangle which looks like that. And this bit here now is just not needed. We don't think that's not part of our shape anymore because it's been popped into here. So now, like with a rectangle, we can think, okay, what is the width? 1, 2, 3, 4, 5. So look, here we go. We've got 1, 2, 3, 4, 5 centimetres, because we've told they're a centimetre each. So that's 5 centimetres, and the length 1, 2, 3, 4, 5, 6 across from here. All this length across here is 6 centimetres. So we can do right in here that our length is 6 centimetres. So to calculate the area, we can do 5 centimetres times by 6 centimetres gives us an answer of 30 centimetres squared. So our area is 30 centimetres squared. Now, in your Power Maths book, you will see that, I'm just flicking to my pages while I'm talking to you here, that question number 1 is doing this method to answer the questions. So if you want to pause the video and work through those using this, that might be really helpful. If you're happy, then just carry on with the video. Now let's have a look at this other way of calculating. This is the same parallelogram as we had on this slide here, okay? We're keeping the same one, but this is using the method where we multiply the base by the height. So actually, even though they've drawn this bit on, we don't need any of this now, because we think, right, the base, how big is the base? Well, look, I'm going to start counting. Here is the base of our parallelogram from here to here. So 1, 2, 3, 4, 5, 6 centimetres is the base. Now the height, remember, now I've got to meet up with the base at a right angle. So here is my height going up here, okay? So that is 1, 2, 3, 4, 5 centimetres. So again, it is the same calculation. 6 centimetres times 5 gives me 30 centimetres squared. So do you see that actually we can either move a bit about? I find that a little bit confusing because I think if you know that the base, the bottom line, gives you your base, and then you work out how high it is by going at a right angle up from your baseline, you're going to be able to do it. Let's have a look at this one. Now B, look, the first part of B is where we're doing our moving part. So what we're doing, this bit here, we can see fits over here to make this turn into a rectangle. So we don't need that bit anymore. Okay, so now the area of the parallelogram, the length one is here, look, is 4, and the height is 2, so the area is 8 centimetres squared. Now for the next one, let's do it by not moving it, even though it's the same picture. I've kept that so you know it's the same one. Let's now do it by doing the base times the height. Okay, so this time we're not moving anything, we're just thinking which is the base. Here's the base, so we've got this going along here. Okay, so that's 4 centimetres, and the height, I've got to come to the corner of my baseline, go up at a 90-degree angle, and my height is 2 centimetres. So actually the measurements that you are getting are exactly the same as when we shift it into a rectangle, but we're finding that height line inside our parallelogram. So the area, 4 times 2 is 8 centimetres squared. Now, I know this is quite tricky. This is quite a confusing one to get our heads around, but as long as you realise that there's 2 different methods here, but you'll come to the same answer, then you'll be okay. Now, here are some for you to have a go at. Now, you can see that these parallelograms, this has moved on where we're not moving parts of it. We're just using the base measurement and the height measurement. Now, A is obvious because it's just got the base measurement here, which is the 5, and it's got the height. We know it's the height because you've got your little 90-degree angle here. So 4 centimetres is your height line. So here for the area, we can do base times the height, which we can do for all of these. But some of them get tricky because they've got the width measurement, they've got the base and the height, and you've got to decide, well, which one of those is the height, which is the width. So I recommend that you have a go at doing this, maybe by pausing the video and coming back. Just be careful with D, because this parallelogram, to find the base, you might have to think of it or in a slightly different way, upside down a little bit. So pause the video, come back, and I'll go through some answers with you. Okay, so for part A then, height times by the base gave us an answer of 20 centimetres squared. Now in B, the base was here, look, that was 8, and the height is 5 centimetres. So for this one, we had to do 8, and we're going to times it by 5, which gave us an answer of 40 centimetres squared. Now on C, again, this is a little bit confusing because when I first looked at it, I thought, oh, my base is here. This is my baseline, 7. Now, 8 looks quite straight, so is that my height? But then I thought, no, actually, I know that 6 is my height line because look, it's meeting here. This is the important part. It's meeting the baseline or the opposite baseline to the measurement we know. It's meeting that with a 90-degree angle. So this must be our height. So for this one, we needed to do 7 and multiply it by 6 to find the area. So the key to this is to look out for those little 90-degree lines to see which one is meeting the baseline. For this one, you should have got an answer of 42 millimetres squared. Now for D, again, confusing, but actually you almost had to look at it this way. 4 metres is my baseline and 3 metres here is my height line. So my calculation here is 4 and times it by 3. So I get an answer of 12 meters squared. All right. Now, this I know is another step harder for area. Now, if you are completely happy with this, please go and work on the power maths pages from 126 to 128. Now, if you are finding this quite confusing and quite tricky, the questions I want you to work on are questions 1, 2, and 3, and that's enough, because that will just get you into the methodology and how to work through this type of calculation, and that's enough for now. So if you're a bit, oh, I'm not too sure, maybe watch the video again, watch a bit, do a question, watch a bit, do a question, because I'm trying to do it that you can look at it to help you through those parts. Obviously, send me a message if you get stuck, and I'll do my best to help you. All right, well done for your hard work, and I will see you now after half term. Have a lovely break. Bye-bye.